Hello everyone, I am Kadre from Bangalore, India, and I am pursuing MSc in AI/ML in collaboration with Upgrade. My major thesis topic is to evaluate Bayesian and multi-fidelity hyperparameter optimization techniques on selected finance datasets. So it's a hyperparameter optimization project for multi-fidelity and Bayesian methods. So outline of this presentation is pretty much the same as my research thesis. And we'll start with a bit of introduction here. So for better accuracy, we all know that all machine learning model needs some kind of tuning and calibration. Hyperparameter tuning again is a very time consuming task, and it requires multiple rounds of training and retraining of model. So we want to, in this research study, we want to help machine learning practitioners to quickly finish their hyperparameter optimization projects with the best possible results. So that's what is our aim. Research questions that we have investigated in this project are to evaluate Bayesian and multi-fidelity of hyperparameter optimization methods on selected finite data sets. We want to see how hyperparameter optimization methods like multi-fidelity and Bayesian, they compare to the baseline results from grid search and random search. We want to check if the choice of machine learning algorithm and any specific choice of hyperparameter optimization method makes any difference to the performance. And lastly, we want to see that if we can make any recommendation, usable recommendations to the practitioner to quickly finish their projects, optimization projects with best possible results. So here I would like to start with a little bit of highlights in the gaps in the literature. So there are many hyperparameter optimization studies available, but there is no universal benchmark for choosing hyperparameter optimization methods whose results generalize well to all possible scenarios and applications. Secondly, there are not many domain-specific studies which are available, and even if they are available, their scope and size is very limited, is not as big as what we have done in this study. So with this aim, we start our projects. So research methodology is pretty much the same as what we follow in any machine learning project. So except the deployment in this, we have followed all the steps. I have chosen these 5 data sets. All are binary classification problems, and they are from diverse sources. And we have done some kind of sampling, and all are publicly available data sets. So then I want to highlight a bit on experimental setup. So overall, in all, we have done 240 independent model runs, which comes out to be 48 model runs per data set. We have used a total of 5 data sets in our study. We have used 6 distinct machine learning algorithms, and for every machine learning algorithm, we have tried out 8 distinct hyperparameter optimization techniques. And in this study, apart from grid search and random search, we have tried out 3 variants each from Bayesian optimization and multi-fidelity families of optimizers. So total 8 optimizers we have tried out. So 8 into 6 into 5 becomes 240 independent experiments. And all the experiments are binary classification type. All the code base is made available in GitHub. Everything is available. But you have to write a request because right now it is private for kept private for security reasons. So you can just write me email and then I can give you a permission. Then I would like to highlight a bit on the results. So here you can see I have presented the results for database 1, and observations are pretty much similar across all the 5 data sets. So here the choice of optimizer is immaterial. So if you choose random forest and XGBoost machine learning algorithms, you can get identical results from any of the optimizers within plus minus 2%. So your choice of optimizers is immaterial. If you choose random forest and XGBoost, you can get almost the identical results from any of the optimizers within plus minus 2%. Others like linear regression and naive Bayes they are giving very average results. And support vector machines and ANN are especially disappointing. So this is one observation. Now, as we saw that ROC AUC values are almost identical for all the optimizers if we choose random forest and XGBoost. So that is not a differentiator because ROC values are identical, ROC AUC values are identical across all the optimizers. If we choose random forest and XGBoost, so that is not a differentiator. So here, the only differentiator that we have used is CPU time. So you can see that BOHB CPU times with random forests are minimum. So 30 seconds for random forest with BOHB, and second best is 197 seconds for BOHB with XGBoost. And we are not considering SVM and ANN because if we use, their sample sizes here are different. And if we use the same sample sizes random forest and XGBoost, support vector machine and ANN are taking way higher CPU time. So they are anyway not considered here. So we are considering only random forest and XGBoost because they are the best performer. And if we use random forest and XGBoost, BOHB is giving the best performance. So now here, as I repeat again that ROC AUC performance is identical across the optimizers if we use random forest or XGBoost. So here the only differentiator for ranking machine ranking optimizers is CPU time. So only one differentiator is CPU time. So you can see that for all the 5 data sets which are listed in these tables, BOHB is the best performance. So right now these tables are shown for random forest CPU time with BOHB, random forest CPU time with all the 5 data sets. So we can see that BOHB is the best performer. And similarly, you can see that similarly you can observe that for XGBoost also, CPU time is the best with BOHB except in the database one. So, out of 10 cases, in 9 cases, BOHB is the best performer. So that is our top rank optimizer. And you can see that random forest with BOHB is giving the best performer. And here we are considering only random forest and XGBoost because they are only the machine learning algorithm which are giving best performance. So other machine learning algorithms are out of question. And if we use random forest and XGBoost, you can get identical results from irrespective of what optimizer you use within plus minus 2%. So based on these experimental and more importantly, these results and these observations are consistent across all the 5 data sets. So we can say that our conclusions are very reliable and they generalize well across the data sets. So here are some recommendations based on our findings. So first of all, first recommendation is that you can get identical best results with any of the 8 optimizers, provided you use random forest or XGBoost. So here choice of algorithm is machine learning algorithm is more important than choice of the optimizer. If you use random forest and XGBoost, you can get almost identical results from any of the 8 optimizers within plus minus 2%. Random forest and XGBoost gives consistent best performance. And the difference in ROC AUC values if you use random forest and XGBoost is within plus minus 2% of the top performance. So within 2% you are getting. Practically they are identical because in many machine learning problem situations you can live with 2% kind of difference. So BOHB again is the best performer. And suppose you are constrained with time and resources, we recommend you to run only one experiment, which is random forest with BOHB. With random forest using BOHB, you can get very close to the best performance, as well as you are guaranteed to get the best possible CPU time. And if you have little more time and resources, you can run one more experiment of XGBoost with BOHB. So it is a possibility that your results may ROC AUC results can improve by 1 or 2%. But in that case with XGBoost, your CPU time will increase multifold compared to random forest. So if you are having a tight constraint of time and resources, run only one resource, which is random forest with BOHB. Next best is XGBoost with BOHB. So we have tried out these results for PRAUC as well as model accuracy. So results are the observations are identical. So with XGBoost, with ROC AUC, PRAUC, and model accuracy and CPU time, we are getting the identical results across all the 5 data sets. So we can say that our observations are very reliable and they generalize well across the data sets. So this can save a lot of time it can save a lot of time on the part of machine learning practitioner and researcher. Go with only one experiment if you are having a very tight constraint, random forest with BOHB, and if you have little more time, go with one more run more experiment, XGBoost with the BOHB. So this can save a lot of time and resources, right? So you don't need to run multiple model optimization experiments. So for future work, we have some suggestions. Like we have right now considered only Bayesian optimization and multi-fidelity. You can include particle swarm and genetic algorithms. We have considered only 6 machine learning algorithms. You can include more machine learning algorithms. We have done this study for classification setup. You can include the regression as well. And we have taken 5 data sets. I think they should be enough to prove the generalizability and the reliability of results. But if you have more resources, you can include more data sets. And in a very generalized study, you can include every possible combination of every possible optimizer with every possible machine learning algorithm. But that may not be so practical. And here we have used sample. We have downsized the data set because of our computing constraints. So you can run these experiments on full length data sets if you have better computing resources. So these are our recommendations for the future work. But still, I can say that we can say that we have used 5 data sets, 6 machine learning algorithms, and 8 optimizers. So it may be enough to prove the generalizability, and you can say that results generalize well across the data sets, plus they are reliable because 240 experiments have been tried out and it should be enough. So once again, I will repeat, if you are having constraint of time, run only random forest with BOHB, and next best can be XGBoost with BOHB. That's all can give you the best possible results. So with this, I end my project presentation, and thank you very much for your attention. So once again, I'm Shailendra Kadre from Bangalore, and my my MSc thesis project was evaluation of Bayesian and multi-fidelity optimizers on finance datasets. So it is based for it is for MSc in AIML. Okay, through upgrade. So thank you very much once again for your attention. Have a nice day.